Okay, for now, so I will just move on to chi-square test. Um, it's very important to know that the chi-square test is kind of test for the independence, and it's really important to remember that it only tests for the categorical data. It's not for the continuous data. Okay, so and it reject null hypothesis based on p-value. Actually, I have mentioned p-value quite many of times in the one ANOVA and two ANOVA test. However, you can still learn the p-values from the link here, which is from Wikipedia also. And usually, right, in our most of our tests, we will just simply compare the p-value with these four significant values. I will call it significant levels also can. Okay, so so these are kind of things that just to remember when p-value is smaller than the significant value, we just reject the null hypothesis. And on the other hand, it means that the data provides sufficient evidence for you to reject the null hypothesis. Okay, and this is the link for you to study more about chi-square test. Okay, another thing to take note for the chi-square test or maybe hypothesis testing is about the test errors. There are two different type of test errors, which one is type 1 error. So about the type 1 error, right, is when the data provide you the evidence to reject the null hypothesis. But actually, in fact, the null hypothesis is true. Okay, so for the type 2 errors, right, is when you want to reject the alternative hypothesis, but actually, in fact, the not alternative hypothesis is true. It is type 2 error. It is good if you can include this error rate in your project, but I'm not going to show you how, but you can still, there are many available resources to teach you how to calculate the error rate. And again, you also can refer to a link here to study more about the type 1 and type 2 errors. Okay, so for now, I'll just demonstrate you how to calculate your chi-square test, how to conduct your chi-square test. Okay, so in this case, right, I made these data sheets for the test. Okay, so let me explain you about this table. So basically, maybe these are the type 1 fish and type 2 fish. Okay, so and this yes or no, maybe you can just I would say yes is means the fish are delicious. The no means our fishes are not delicious. Okay, so maybe for this 25, it means that the type 1 fish is delicious, which means that there are 25 fishes from 25 type 1 fishes is delicious, and 16 type 1 fishes are not delicious. Okay, so regarding this 25 here is 25 type 2 fishes are delicious and 19 are not delicious. Okay, so the total number here 50 means in total 50 fishes are delicious, including type 1 and type 2, and 35 means total 35 type 1 type 2 fishes are not delicious. Okay, so similar here 41 means there are total 41 type 1 fishes I have observed, and 44 type 2 fishes I have. Okay, so let me show you how. So the first step, okay, is to let's calculate the percentage first. Okay, so simply we just this one. So let's calculate the delicious fish percentage proportion and the non-delicious fish proportion. Okay, so okay, now let's move on. We need to okay, so for the chi-square test, right, we just remember we need to calculate the expected value from this percentage, like what we did for the PP plot previously. Okay, so but it's easy, so we just use the total number maybe of fish run times up the percentage here. Okay, so times up the percentage here. Okay, so again let's so now we can see these four are the expected value that we want to see. Okay, so let's move on to calculate the p-value for these two data sets. Okay, actually in here I have done the templates already, but I will just redo again. Okay, so let's just use the chi-square test. Okay, so it's the actual range, which is the original data, and the expected range. Okay, so put bracket, let's run. Okay, so remember p-value always compare with the significant value. So in this case, we just use most common one, 0.05 again, and we will see that the p-value is much bigger than the 0.05, right? So okay, in here I use if else statement to tell if yes or no. Okay, so what can we conclude from this p-value? So because p-value is bigger than the significant level, so we cannot reject the null hypothesis. Okay, so in other words, that data doesn't really provide sufficient evidence for us to reject the null hypothesis. And maybe we can further conclude that type 1 fish and type 2 fish, actually there are no difference. Okay, yeah, so basically that's all about the chi-square test. Okay, so to